circle properties, triangle similarity and congruence, powers of negative integers and zeros of polynomials. MCQ numbers. Tangents at diameter endpoints. This is the topic. Under this concept, this question is asked. The tangents drawn at the extremities of the diameter of a circle are always A parallel, B perpendicular, C equal, D intersecting. Yeah, the correct answer is parallel. The tangents drawn at the two endpoints of any diameter are always parallel to each other. Well, how? Yeah, if you look at the picture, a circle with the diameter and two tangents drawn with the point of contact as the extremities of the diameter A and B. Two perpendicular lines drawn to a given line are parallel to each other. This is the theory behind. Now let us see the explanation part. While the answer being parallel, A, option A is correct. Yeah, let us see the explanation in detail. Yeah, first one is tangent property we are using. A tangent to a circle is always perpendicular to the radius at the point of contact. This is a fundamental theorem in circle geometry. Second one, diameter property. A diameter is a straight line passing through the center of the circle, connecting 2 points on the circumference. Parallel lines theorem. Two lines that are both perpendicular to the same line must be parallel to each other. This is a key geometric principle. These three properties combine to prove that tangents at diameter endpoints are parallel. Option A, parallel, is correct. MCQ 8. Yeah, this deals with triangular congruence and similarity. Given two triangles ABC and DEF, where angle B equal to angle E, angle F equal to angle C, and AB equal to 3DE, what is the relationship between these triangles? In the picture already, ABC and DEF triangles are shown with the proper proportion. Angle B is angle E, angle C equal to angle F, AB equal to 3DE. If DE is taken as X, AB will become 3X with a scale factor of 3. Now, the answer choices provided are: these two triangles are congruent but not similar, congruent as well as similar, neither congruent nor similar, similar but not congruent. Now, option D is correct, similar but not congruent. The triangles have the same shape but different sizes is the observation. Based on that, we can easily conclude that they are not congruent but similar. Let us see a detailed explanation. Here, option is D. D is the right answer, and we move to the explanation part. Yeah, the given data. First, let's take angle B equal to angle E, angle C equal to angle F. So the corresponding angles are equal. If two angles of a triangle are equal to the corresponding angles of another triangle, the third angle automatically follows the equality, because 180 minus these two angles gives the third angle. So by that property, third angle is also equal. Therefore, angle A and angle D are also equal. Now, we have seen that all the three angles are equal. Yes, this being the case, we can call them similar, because Similarity of triangles means when all three angles of a given triangle are equal to the corresponding angles of another triangle, then these two triangles are said to be similar. Therefore, triangle ABC is similar to triangle DF. Okay, let us see the congruent part. What is congruence? Two triangles are said to be congruent if and only if they have the same shape and same size. This means all corresponding sides must be equal in length and all corresponding angles must be equal. In the given problem, we are told that AB equal to 3D. If D is taken as x, AB will become 3x, right? This means side AB is 3 times as long as the corresponding side DE. Now compare corresponding sides. Since AB is not equal to DE, the corresponding sides are not equal in length. This violates the requirement for congruence. So final conclusion is, because the corresponding sides are not equal, the triangles cannot be congruent even though they are similar. Fine. Further explanation goes in the next slide. Comparison of similar triangles, congruent triangles. Same shape is common in both. All corresponding angles equal is also common. Sides are proportional, not equal is similar property. All corresponding sides are equal is congruent property. Here they are differing. Different sizes allowed for similar triangles, but identical sizes must for congruent. Scale factor can be any positive number in similar triangles, whereas scale factor has to be 1:1 in congruent triangles, exactly equal. Yeah. In the given case, triangle ABC is similar to triangle DF with a scale factor of 3:1. Whereas if ABC and DF are supposed to be congruent, then they are supposed to have 1:1 scale factor. So DF should be exactly of same shape and same size. Then only we can write triangle ABC is congruent to triangle DEF. The symbols for similarity and congruence are provided there. Yeah, you can observe it. Now, what is key insight? All congruent triangles are similar, but not all similar triangles are congruent. Congruence is a special case of similarity where the scale factor equals 1. Okay, here we move to next question. Powers of -1. Okay, what is special about it? This is very very important to understand in algebra or in any part of mathematics. This -1 raised to power of certain power will always be deciding the polarity of the number, the sign of the number. So how? If n is even, -1 to the power of n, if n is even, it is positive. If n is odd, it is negative. Let us see how the question is incorporating that concept here. Question is, solve for n in the equation. Okay. -1 to the power of n plus -1 to the power of 8 equal to 0. Answer choices given are n can be any positive integer, any negative integer, any odd number, any even number. Fine. Here the answer is any odd number. That is correct. Option number C. The value of n must be any odd integer, positive or negative. It doesn't matter. It has to be odd. For the equation to be satisfied, in order to satisfy the equation, n has to take an odd number. Okay. Explanation goes like this. Minus 1 raised to power of n is positive when n is even. Examples are minus 1 whole square is 1 plus 1. Minus 1 to the power of 4 is 1. Power 6, power 8 and power 10 all are even numbers and they result in 1, positive 1. Because minus into minus is plus. So always even number will provide you a positive 1. If n is odd, say minus 1 to the power of 1, that is minus 1 taken only one time, it is minus 1. If it is taken 3 times, it is also minus 1. So is true in case of 5, 7, 9 and any odd number including negative odd numbers. Why? If negative odd number is there, then this minus 1 to the power will go to the denominator. Whether minus sign there in the denominator or numerator will make no difference as far as sign is concerned. Therefore, minus 1 you will get. Now, minus 1 to the power of 8 definitely is a plus 1. In order to make it 0, I must have a minus 1 associated with that. In order to get a minus 1, n should take an odd number. So, this is the explanation part.